All right, hey math 20-1. So now we're getting into, instead of multiplying and dividing these expressions, what we're going to be doing now is adding and subtracting these expressions. And it gets a little bit more difficult than multiplying and dividing because if you remember when you add and subtract fractions, so if I had something like, I don't know, let's say 4 over 3 plus 2 over 5. Remember that we can't just add those straight across, right? Like you can when you're multiplying. Multiplying was easy. You're just, bottom times the bottom, top times the top. But when we're adding fractions, we have to, we have to make sure we have a common denominator. So we need to rewrite these expressions in terms of a common denominator. So I'd say, what does 3 and 5 both go into? So 3 and 5 both go into 15, right? We can multiply 3 by 5 to get to 15. So what we have to do, though, if we want to do that, is I want to rewrite, this expression, but being over 15. So if I did that, what I would want to do is multiply the bottom and the top by 5, right? Because that would give me 15 on the bottom. And I had to also multiply 5 by 5 on the top because if I didn't, I'd be changing the expression. This way I've got 5 divided by 5. I'm only really multiplying by 1, which is like nothing, right? So if you multiply by something on the bottom, it has to be on the top, or else you're changing things. So we multiply that by 5 and that by 5. And I look over here and say, okay, what do I multiply 5 by if I want the denominator to be 15? Well, I have to multiply that by 3. But if I do that, I also have to multiply the top by 3. So if I rewrite this expression over here, I end up with well, the top here, 5 times 4, this would be 20 over 15, plus 2 times 3 is 6 over 15. Now we did all that just so that we could have 15 being the denominator for both, because now that we have that, our answer is going to be over 15. The answer or the denominator stays the same, and then the numerator, we just now add them. So 20 plus 6. So this would be 26 over 15. Okay, so that's a little review about just adding fractions. Now we have to apply that to polynomials. Okay, so if we're doing this question, lucky us, the first easier ones already have a common denominator, right? They're both 24x y squared, 24x y squared. So this one's simple enough. All we have to do is we'll keep the denominator the same, and then the top though is going to be 6x minus 6y, because that was just this part, and then minus 5y, just because I'm just subtracting that, right, over 24xy squared. Now the last step, I just need to collect my like terms. So my y's, I've got 2 y's up top, so I'll rewrite this as 6x minus 11y over 24xy squared. Okay, so I'm going to carry on with a couple more here. I just wanted to show, this will be a situation that might get you though. I'll show you what I mean in a minute. Again, we've got common denominators, so these ones are pretty straightforward, right? We just keep the denominator the same. So we know our answer is going to be over, something over 30m squared n squared. And then the top though is going to be 6m minus 2n, and then minus, but then what we have to make sure we do is put this in brackets, m minus 5n. That has to be in brackets because we're subtracting that whole term. If you didn't put the brackets there, then you'd end up getting the wrong answer, because when I rewrite this below, I'm going to have 6m minus 2n minus m, that's just this part, right? But then I've got a negative times by the negative inside, that's going to end up being plus 5n. That's the part right there that gets people. So that is all over, or sorry, my pen's not working very well again. I think I need to go get a new pen. But anyway, so 30m squared n squared. And then last thing we gotta do, we got some n's and some m's up top that we can just simplify. So let's just write that over here. That ends up being 5m, right? Just collecting like terms. Stupid pen. 5m. And then we got a 5 here and a 2 there. That becomes 3. So plus 3n over 30m squared n squared. All right, next step here. I'm just going to show you that we're going to be able to start canceling things just like we did in the last videos too. So again, we've got the same denominator, so that part's easy enough. But the top, let's just make the top go right across. So let's add the top. So we've got 2p plus p plus 3. Now I could put that in brackets, just like I was saying before, but since this is a positive, it's really not going to make any difference, right? If you take the brackets out there, it doesn't really matter, right? So we've got that over 3p plus 1 squared. If we simplify that, so I'll just going down here, let's say that was equal to, we're going to have 2p plus 1p, so that's going to be 3p plus 3 over 3p plus 1 squared. And now what I'm going to do in the next step here is I'm going to factor a 3 at the top. So if I do that, I've got 3, and then what I'm left with is p plus 1 over, and now I'm going to write this bottom term, or the denominator, a little different. I'm going to write this as 3, and instead of p plus 1 squared, I'm going to write this as p plus 1 times p plus 1. Now you can see that, well, the 3's up top are going to cancel. So that cancels with that. But then I've also got p plus 1 and one of my p plus 1's at the bottom canceling. So in the end here, my answer is just going to be 1, because there always has to be 1 up top, right? Even if you cancel both of them. 1 over p plus 1. And that's my answer. So I'm going to let you guys go ahead and try this one, and I'll just pop up the answer here in a minute. Okay, so there's the answer there. Moving on down. Okay, so now you're looking at this one, and for the first time, we don't have the same common denominator. And actually, you know what? I'm going to end this video here, and I'll start the next one so we can kind of keep it separate. So I'll see you guys in the next video.